All right, thanks, Amanda. Let's go to the next slide, please, Sam. So it's my honor to be with you all here today virtually to talk about what Goddard is looking at for this pre-phase A study that has been alluded to several times today. We've talked at LPSC earlier this year about LExSO. We recognize that right now there's an incredible renaissance in lunar science and exploration going on. We're in the beginning stages of that. LRO has been quite honestly and humbly kind of one of the most important drivers of this renaissance. We see a number of missions that are planning to go to the surface of the moon in the coming years. LRO has been the guidepost for those missions, and we know that there will always be a need for additional site reconnaissance. LRO has shown the need for additional high resolution data sets. We also recognize the need for contemporaneous measurements while missions are operational. And I think the example that Joel alluded to earlier of the featured image release that occurred earlier this week of the LROC capturing the the impact site of the Hokuto R, the ice-based lander, is one of the more, quite honestly, one of the, even though it's a sad outcome of that mission, having a spacecraft like LRO available to image the impact site to provide details as to what happened is incredibly valuable. I want to also highlight something about this finding that may have kind of lost people's, not been obvious to folks. In that featured image that was released on Tuesday, if you look, there's a before image and an after image. I had the after image shown here. The after image was collected about 12 hours after the planned landing time. The before image, the fundamental piece of information that we had that could show that surface change, was acquired on May 26th, 2012. That's not a typo. It was not 2021. That was, as of tomorrow, will have been 12 years ago. 11 years ago. Math, never my strong suit. We were able to find that change because we have this incredible baseline of observations thanks to the LRO spacecraft. And so what we, I think, can take away from the ClockSat report that Ben alluded to a moment ago is that the need for an orbital mission is clear, and the need for supporting active missions, landing, operating on the surface, is obvious. Let's go to the next slide, please. So lunar science has changed dramatically in the 14, 13, 14 years since LRO launched. I mean, we're getting to the point where we have a teenage spacecraft, and thinking about what comes next is critical. Missions take time to evolve, to develop, to launch. The ClockSat report outlines the need for high resolution data, but also for long-term, long baseline observations of the lunar surface, the lunar environment, to see how that changes as a function of time. LRO is currently the longest lived lunar orbiting mission. We are currently funded through 2025 in our fifth extended science mission proposal, and we will and are preparing for a sixth extended science mission proposal that will take us from 2025 through 2028. That said, looking ahead as to what comes after LRO is timely, is critical, and we agree with the findings of the ClockSat report that we need to be doing this, and we're very fortunate and glad that headquarters recognizes this and has funded Goddard to perform a pre-phase A study. Let's go to the next slide, please. Here's a timeline. LRO ESM5 is going, as I said, until 2025. We are very eager to see the results of Artemis 3. Obviously, I'm extremely interested in the results of Artemis 3, but as they relate to how LRO can make coincident observations of that mission is obviously very timely. And following that, LRO ESM6, which will take us through 2028. Getting a spacecraft in orbit at the same time as LRO is going to be critical. And again, we're on the clock for that. So as part of our LExSO study is how do we get a mission orbiting the moon, a capable mission orbiting the moon, as quickly as possible. Let's go to the next slide, please. I know this is not something that maybe rolls off of everybody's tongues easily, certainly not mine. What is a pre-phase A study? This chart that I harvested off of some lost NASA website outlines the project life cycle. Pre-phase A is a concept study. This is purely a look at what is feasible and how much would it cost. This is not a funded mission. It's not going to, show up on the books as definitely going to launch by a certain date. We're assuming certain things about when we could launch, when we would want to launch in order to meet that goal of operating contemporaneously with LRO. And what we're really doing is laying out what a mission could look like. What capabilities should it have? What are the instruments it should have? What are our requirements for an orbit, for data? All of the things that Ben outlined that the ClockSat report really clearly outlines and delineates. As part of this, we're looking at what are the needs of the science community and what are the needs of exploration. In this exciting future era of lunar surface exploration, we recognize that there are going to be demands for orbital assets, orbital data that LExSO potentially could provide. And as I said, headquarters has funded this pre-phase A study that would hopefully get future approvals to continue on into formulation and eventually into implementation. Let's go to the next slide, please. And I'll answer your question eventually, Renee. I'm not sure if I'll get to it in this 10 minutes or not, but definitely we'll try to. So Ben walked through all these overarching findings, but we really took the ClockSat report to heart and used it as the, if I could butcher some French, the raison d'etre for what we want to do in lunar orbit. We agree. We need to have continuous lunar orbital assets that is available to NASA. We are planning this next generation suite of instruments for an orbiter that could live, quite a long time. We put into the survey meeting later this year a bit of an engineering talk on what it means to be a long-lived lunar orbiter. There's a misconception. Remember, LRO was supposed to last 2 years, maybe 3 years. Here we are going into our teenage years now. It was not built as a decades-long mission. We're just benefiting from its construction and its implementation that allows us to have it orbit this long. And we totally agree that a single spacecraft will not answer all of the questions. As y'all will lay out in the next few slides, hopefully, that there are instruments that we've considered that we don't think we can fly or support in an LRO-like environment, an LRO-like spacecraft that should find a home on future orbiters, but that potentially a mission like LExSO would not be appropriate for. I agree that high resolution measurements are critical. Let's go to the next slide, Sam. And that basically getting global data is going to be key for not just supporting missions, but for furthering lunar science. Getting long baseline observations, we can only propose a multi-year mission, but that a mission that is extended over several iterations could provide a long-term baseline for observations. That we have to look at new generations of instrumentation of how we operate and maintain a spacecraft, and use communication assets on the spacecraft as well as on the ground are going to be critical. Let's go to the next slide. And lastly, that having a range of options or orbital assets, instrument assets, is going to be critical for any future spacecraft. And so these findings and the details in the ClockSat report, basically gave us the green light to go ahead with our study. Let's go to the next option, next slide here. As Ben clearly alluded to, we got a subcommittee of the LExSO, the ClockSat team, to look at prioritizing the myriad of payload categories, opportunities that they elucidated in the report, and came up with this set of 6 observation measurements. We took those priorities and compared them against what we had been considering for instrument options, and fortunately there's beautiful overlap between the two. Let's go to the next slide, Sam. I'm rounding into home here. So in the last minute, we put together a preliminary science team, and this is an important point. Renee, the last line is the key one for your question there. I have been serving as the project scientist. We put together a small preliminary science team to support the development of this mission concept. We've got inputs not only from ClockSat, but from exploration communities, both the Artemis mission planners, some of the ISRU experts from across the agency, to provide us their inputs, their requirements, their requests. With that, next slide, we've pulled together a suite of potential instruments. We recognize the need for high resolution imaging, laser altimetry for both altimetry, measuring topography, but also for laser spectroscopy, removing the tyranny of the sun from the equation and allowing us to peer into these areas of permanent shadow or into areas that are unilluminated, nighttime observations to determine abundances of volatiles, a multi-band imager for water and compositions, as well as the other measurements that you see listed here. Those match up nicely with the ClockSat prioritized list. And there is some nice overlap with Lunar Trailblazer. If we go to the next slide, some words of wisdom to leave with everybody here. Look forward to hearing more questions, community inputs, and certainly look for community support to ensure that ClockSat report feeds into LExSO, which becomes a reality. I'll end there.